Hi. Since we're talking about evolution, it's probably time to go out and look for some evidence for evolution. So I'm going to go out and look for fossils, both in the valley back below me. That's kind of my backyard, and down in a creek bed down at the bottom of my subdivision. So on the next time you see me, you'll see me probably in a different sweatshirt. I've been out on a number of different days looking for fossils, and I'm going to go ahead and put all these little videos together into one single video. The ground's getting a little dry now. It was easier last week. Here's another stone. Sometimes you find fossils in these stones, and I don't know that this one's going to have one. Let's see, I'd have to look. So it's pockmarked. I don't see any fossils in this one, but this is limestone, a limestone base that we're on here. So you never know what you're going to see when you got limestone. Limestone, usually it's a sedimentary rock, so you got a lot of fossils in it. So as the valley slowly erodes away, the stones, more and more stones come popping up. And I'm sure that we've probably lost, before we bought this house, a significant amount of topsoil washed out. Here's some more stones. There's a pretty good sized one there. There you go. So right there in the fossil, do you see that? That's the central region, I believe, of a crinoid. This rock was mud on the bottom of, at one time, an inland sea, and so there are fossils of marine creatures here, and there's one right there. And I'm sure there's more in this rock if I whacked it open with a hammer. So I'll go ahead and take that. You can see it right there. I'll go ahead and take it up top and go over it with a magnifying glass, and maybe I can get that on film too. I'll bet there may even be, so there are fossils in here. See, they've been eroded, but there may even be a little trilobite sitting in here. So here we are down in the basement. We're taking a look at some of the fossils I found in the valley down in the riverbed. This first fossil is the one that was picked up down in the valley, and that right there appears to be the skeleton of a crinoid. The outer shell of the crinoid is the outer edge of the tube here, and this pattern on the inside is its internal. It's not really a true skeleton necessarily, but it's its internal body structure. What's missing is the soft arms of the crinoid. Crinoids are like starfish that grow on a stalk, like a little tiny stem, and they wave their arms in the water and they catch food to eat. This was the stalk of such an animal. The rock probably contains a lot of other fossils, but I'd have to break it open in order to see those. And this one, we just got lucky. It happened to be exposed on the surface. Hi, so now I'm down here. This is the bigger of the lakes in my neighborhood. And what I'm about to do is walk below the dam wall down into this creek here. This is called Cox Creek. And the gravel bar down there has eroded limestone and dolomite, probably not dolomite, mostly limestone, that has tumbled from rock formations upstream. So the river, the creek, is cutting through bedrock, and when it does, it picks up rock. So anyway, I'll be walking down there. I'll sign off for a second so I can attach the camera, and we'll take a walk down there and see what kind of fossils we can find. Talk to you in a minute. Bye. So here we are down in the creek bed, and we're going to go take a walk. The other day I was in this section, so I don't want to look here again. We're going to go up past this fallen sycamore up ahead and see what we find. These larger rocks that you see on the ground here, they're all eroding from some bedrock formation upstream here, and they have fossils in them, and they're pretty badly tumbled down here. So we want to go upstream a little bit and see if we can find some that are a little less tumbled. So that, you know, down here on the creek, we're hundreds of feet lower in elevation than my property up where we were before looking at honeysuckle. And down here, the creek is actually cutting into bedrock, and it's in so doing, it's picking up stones and washing them down. So what I got to walk around here is this white skinned tree right here is a sycamore tree. Sycamores we're America's largest hardwood tree. The champions are over 10 feet in diameter. They were massive. Of course, the early settlers didn't know what they had, and a lot of them cut them down right away. People used to live inside of them. They'd be hollow. Apparently, the stories are people lived inside of them while they were building their cabins. This one here, see, it lost its perch on the riverbank over there. It's come around the corner here. Right there. So in one of our flash floods, the river cut around the soil too much, and the tree lost its grip on the riverbank there, and it knocked it over. All right, so here's one of our big chunks of rock here, and all these little bits you see in the rock, these are fossil traces. So this section of this rock here is full of fossils. See, this is a end of a crinoid. Crinoids were stalked. They look like starfish on a stalk. If you can imagine a starfish on a little stem like of a tree, that's what crinoids were. They live today in the oceans, so they call them feather stars. And so that's the stalk of a crinoid. These little holes, those are worm tunnels that were tunneling in the mud about 300 to 320 million years ago. This was a mud on the ocean floor at that time. And let's see if we can find any other. So this one's worn pretty badly, but these holes that are in the rock are probably fossil traces. Hard to say what they are anymore though, because they're so badly eroded. Okay, so I thought I'd film a little bit of this. You can see this section of the creek here is running kind of fast, and the creek actually runs against this dirt bank, and you can see the layers of rock in the dirt bank. The upper layers are all soil, a lot of plant roots, worms, things in there, and then right underneath of that is gravel, and it's that gravel bed that actually has the fossils in it that are washing up as the river cuts down through. So I'm standing on gravel here because the river has cut through the soil and exposed all this underlying rock. And so as I walk up here, I'll let the camera run for a little while. I haven't found any extremely large fossils, and I think I may be passing the richest part of the fossil bed, because behind me there were numerous rocks with small fossils in them, and I'm finding fewer here. So I may be past the richest part of the fossil bed, but you know, it's worth taking a look. I walked up here a couple days ago and caught a little bit of film footage here. So again, this is fossils from the same bed. All these small spaces and things are worm tunnels that are in the rock. A microscope can actually reveal more of to the naked eye, it just looks like a rock with little holes in it. You can see, so in this particular stone, you see the imprint of a shell, bases of crinoids right there. Those are crinoid stalks. And then all these little wormholes that are in the rock represent, you know, traces of life from a long time ago. I'm not sure if these fossils can be dated absolutely. Relatively, they come from the Carboniferous and or the Mississippian periods of the Paleozoic era, which is before the age of the dinosaurs. So there were no dinosaurs running around. You can see this one really well preserved. See the fine detail? I don't know if you can pick that up on the GoPro. Right at the edge of my thumbnail there. Some really fine detail in the crinoid skeleton. So this particular stone has some really good fossil prints left in it. Most of the ones I'm walking over though, see, they're heavily eroded because the river tumbles the rocks and it just beats the daylights out of them. So this particular stone in my hand must have gotten preserved somehow. So there are a lot of stones here again that could have some good fossils in them. I haven't found any trilobites yet, but you know, this may be predating the trilobites. There are other rock formations in Missouri where if you really wanted a trilobite fossil, you can go get one. They're there. Now, suddenly, if you'll notice on the stream bed here, all the stones are smaller. That's a sign that we may be leaving the richest part of the fossil bed, but we're going to walk upstream a little further and see what we run across. So here's one of the big rocks on this gravel bar. That's a crinoid stalk tube right there in the rock. Not much else in this rock, but I thought I would show that. That right there, that ribbed tube right there is definitely a fossil crinoid, which is the Missouri state fossil. So this rock's a really good example of the layering. I don't know which way is up or down, but you can see in the formation of this stone, we have layers of heavy fossilization and then areas, maybe this is a cataclysmic flash flood, a whole bunch of material washed in and very little fossils. And then this was laid down more slowly. You can see the different layers that are, and there's all kinds of little fossil imprints in this rock. This one's worth bringing back. And now here I am in the basement. We're looking at the fossils that came from the riverbed. This first one's got all kinds of small fossils in it. It's not a very big rock, but it's got a lot of imprints in it. That right there is probably looking down the shaft of the stalk of a crinoid. And there are all kinds of other small imprints in this rock. The rock on the other side doesn't look that eventful, except that it does have the skeleton of a crinoid at that edge right there. It's a small piece. This section right here has a number of imprints in it. That may be the sections of a nautiloid that were broken away. So this side here has a number of other interesting things to look at. And I believe that right there at the tip of my thumb, that fossil right there, that may be a mold of the top of a trilobite. That's what they look like. It's almost like the back of a bug. Trilobites were sort of like the primitive crayfish of the oceans over 300 million years ago, and that looks like the back end of one right there. So that's the first of the rocks. The second one here, this one's absolutely loaded with fossils. This one just got lucky. It happened to be fractured right at a particular zone where just hundreds, if not thousands, of animals died, fell to the ocean floor, and got fossilized. So if you look carefully, you can see all kinds of imprints. There's pieces of crinoids. There's a few clamshell imprints. There are just all kinds of bizarre shapes, many things that we may never know what they were. There's an interesting shape right here. Don't exactly know what that shape was, but it could have been some kind of a snail or gastropod, and that was the remnants of the shell. The rock probably, I'm looking at the back face, there's not too many fossils exposed back here, but on the other side, they're just tremendous number. Chances are if we broke it open, we would also see a whole lot of fossils on the inside. The next fossil I brought back has some interesting sections. There's a crinoid again there on the edge. There's fossils exposed right here in the edge, on the side. And then looking at the edge of the fossil, I'm trying to find it. And then on the back side, there's a hint here at, there could be things on the inside. This is looking at the external tubular skeleton of a crinoid there. Chances are this smooth-looking stone, if we broke it open, would have a number of fossils, on the inside. This edge right here, where it's eroded open, shows there are worm tunnels on the inside. Worms tunneling in the sediment, leaving their tubes. The worms themselves are gone, but the tubes that they left are fossilized. And this last big rock is the large one. Let's see if I can get it in front of the camera here. This is the great big rock that showed the layers that was on the film. As I slide this back and forth, this layer is just absolutely rich in fossils, just absolutely loaded. And then there's a section here no fossils. It's hard to say what happened. Chances are, though, this was a cataclysmic series of flash floods, a whole lot of mud washed into the ocean, and the sediments built up, and there was very little chance for fossilization. And then we have another layer here with a whole lot of fossils in it. You can see all kinds of crinoid marks, all kinds of worm tunnels that were left in the mud. So this fossil here also shows the layered nature of sedimentary rock. You know, the upper layer here, or lower, whichever way you look at it. It has lots of worm tunnels, and then there's a dead zone. There's no fossils, and then there's an extremely fossil-rich zone, and then there's another dead zone. So these were laid down. This is millions of years of time written into the mud. Anyway, that's it for the fossils. We'll move on to something else. I've got honeysuckle removal videos, videos of animals on the property. We'll try to bring biology to life here in the next few weeks.